Okay, so today we're going to be working through this question here, question 2, Math Extension 1, HSC 2018, question 1, I believe that's what that little 1 means. Polynomial 2x to the 3 plus 6x squared minus 7x minus 10 has zeros alpha, beta, and gamma. What is the value of alpha, beta, gamma outside of alpha plus beta plus gamma? Okay, so let's recall our this one here, that there will be what we're going to be working with. So for ax to the 3 plus bx squared plus cx plus d equals 0, let's write that. A x to the 3 plus alpha plus beta plus gamma equal to negative b on a, negative b on a, alpha beta plus alpha gamma plus beta gamma is equal to c on a and alpha beta gamma is equal to negative d on a. Okay, so our polynomial is 2x to the 3 plus 6x squared. So 2x to the 3 plus 6x squared plus minus 7x minus 10 minus 7x minus 10. Okay, so we're looking for the value of alpha beta times alpha beta gamma times alpha plus beta plus gamma. So alpha beta gamma side of alpha gamma. So for a polynomial question like this, we don't actually want to solve for the alpha, the beta, and the gamma. We want to rearrange them or find a way that we can keep them in this form and not have to solve each one, but know what these equal to. So for this one, alpha, beta, gamma is equal to negative d. So we got A, got our B, got our C, got our D. So negative d, so alpha, beta, gamma is equal to negative of negative 10 on 2 is equal to, negatives cancel, so we're going to get 10 on 2 is equal to 5. Okay, and alpha plus beta plus gamma is equal to negative b, which is negative 6 on 2. Negative 6 on 2 is equal to negative 3. Okay, so now we have 5 outside of negative 3 is equal to negative 15. There we go. answer B. Easy peasy. If we can find another question that uses polynomials like this. We're looking for the alpha, beta, gamma. We're not going to worry about this. I'll do that in another video. Actually, remainder theorem. We can do that. What is the remainder when... Is that the same polynomial? No, it's not. Let's go over here. So we got 2x x to the 3 minus plus 6x plus 2. It's divided by x minus 2. The remainder theorem says if we make this equal to 0, and then we plug that x value back into here, then so we make this equal to 0, solve for x, put the x value we get back into here, then we will get our remainder. That would happen if we did polynomial long division. So let's make x minus 2 equals 0. So add 2 to both sides, so x is equal to 2. Now, 2 outside of 2 to the 3 minus 10 outside of 2 squared plus 6x up, not 6x, 6 times 2 plus 2. So 2 times 2 to the 3, which is going to be 8, so 2 times 8 minus 10, 2 squared is 4, 10 times 4 plus 6 times 2, which is 12, plus 2. So 2 times 8 is 16, minus 40, plus 12, plus 2 is plus 14. So 16 plus 14 is going to be 30, minus 40 is equal to negative 10. So is negative 10. There we go, B. That would be our answer for that. So okay, let P of x be a polynomial of degree 5. Let's go back over here. Let's move up to here. Keep that little. Go to here. Okay, so we got 5 x to the n. P of x is divided by the polynomial q of x. The remainder is 2x plus 5. Okay, which of the following is true about the degree of q? So, degree 5, sorry. Means it must start with an x to the 5. Ax to the 5 plus bx to cx to the 3 f. So the following is true about the degree of Q. Okay, so here's what we know. For the degree to be 1, the remainder would be constant. So if we do our polynomial long division, here, if we do our you know, as we go down, the remainder must be equal to a constant. Remainder must be equal to a constant if dividing by a degree 1 polynomial. So, we can put, it's not going to be that one. So, no, it's not going to be that one because it's not going to be a 1. Now, the degree must be 2. Okay, so for the degree here, so the degree of this polynomial must be greater than or equal to 2 but also less than or equal to 5. So, it's not saying that it must be 2. It doesn't have to be 2. But it could be 2. That's probably not my best explanation, but that's what we're going off for now. So next polynomial question. I'll do another video and I'll do the combinatorics questions. Find us another polynomials question. Okay, we'll try this one here. Question 29. Oh, Math Extension 2. We're not doing that. I'm only a Math Extension 1 student, so I can't show you how to do that. I don't know how to do that. Okay, so let's try do this one. Question 34, Math Extension 1. HSC 2002, question 4B, III. Let's write down in here what we know. Know our root theorem here. Let's keep that handy. So now let's work up here. So, what do we know? P of x is x3 minus 2x squared, 2x squared plus kx plus 24 x plus 24. Alpha plus beta plus gamma is equal to 2. So alpha plus beta. I said an alpha beta gamma is equal to negative 24. is known that two of the roots are equal in magnitude but opposite in sign. Okay, find the third root and hence find a value of k. Okay, it's funny that they say a value. Okay, let's try and solve this. So our other one that we have is alpha, beta, plus beta gamma is equal to C on A, which is going to be K is equal to K. It's known that two of the roots are equal in magnitude but opposite in sign. So, what do we know by that? We know that alpha is equal to negative beta. We know that beta, oh my god. Or, there's a lot of things it could be. Alpha is equal to negative gamma. Gamma is equal to negative alpha. Beta. Beta. Okay. So it doesn't matter which way we put the roots. So let's choose this one here. Alpha is equal to negative beta. So alpha, negative, so we got negative beta plus beta plus gamma is equal to 2. Oh, this makes it easy. So negative beta and positive beta will cancel. That means gamma is equal to 2. So now let's do the same thing with this one here. Wherever we see an alpha, we're going to put a negative beta. So negative beta times a beta, negative beta squared, gamma is equal to negative 24. Now we know that gamma is equal to 2, so negative beta squared, negative times 2 is equal to negative 24. So negative 2 beta squared so let's times both sides by negative 1. We're going to cancel out the negatives. So 2 beta so now we got divide both sides by 2. We're going to get beta squared 12, and then beta is equal to root 12. We're going to take the root of both sides so we can cancel out that squared there. Now root 12, let's write that. It goes down into root 4. Root 3, and now root 4 can simplify to 2. It's going to be 2 root 3. So beta is equal to, let's give that a little colourful underline, can find that easily. So, now let's solve this one here. We know that alpha is negative beta. So, negative beta squared plus negative beta gamma plus beta gamma is equal to k. Now, we know that gamma is equal to 2. Where do we see that? We saw that over here. So now, let's put in and substitute in gamma is equal to 2. So negative beta squared plus negative beta times 2 plus 2 beta is equal to k. So beta squared is equal to 12. So we can just go negative 12 there, minus 2 beta. Oh, look at this. Get even smaller. Minus 2 beta and plus 2 beta will cancel out. So negative 12 is equal to k. K is equal to negative 12, the third root of k. Let's check our solutions. What question was this? This was question 34. Look at that. There we go. That there is very good. I think I deserve a pat on the back. I'm very happy with myself for that. Let's minimize that. There's another polynomial. Math extension 2. We shall not be embarking on that journey. Okay, this is an easy one. Question 24. Let p of x equal x cubed plus 3x squared minus 13x plus 6. Show that p of 2 is equal to 0. Okay. So let's go over here. So x cubed plus 3x squared minus 13x plus 6. Show that p of 2 is 0. If you want to stop and pause the video, feel free. I think this would be a good one to try and do by yourself. So, when they say p of 2, they just mean every time we see an x, we're going to put in a 2. So, we're going to have a 2 to the 3 plus 3 times 2 squared minus 2 plus 6. So 2 to the 3 is 8 plus 3 times 4 is 12 minus 13 times 2 is 26 plus 6. So minus 26 plus 6 is minus 20. 8 plus 12 is 20. 20 minus 20 is equal to 0. There we go. Extension 2, not going to be doing that one. So, find the polynomial q of x that satisfies x to the 3 plus 2x squared minus 3x minus 7 is equal to this times that plus 3. So let's write this out. Let's go down the bottom here. Let's write out our question. X to the 3 plus 2x squared minus 3x minus 7 is equal to x minus 2 times q of x deeply apologize if you guys can hear that chainsaw in the background, plus 3. Yes. We're going to move the plus 3 to this side. So we're going to get x to the 3 plus 2 times q of x. Okay. So now let's divide both sides by x minus 2. So now we know that, I'll put a big fraction bar, x to the 3 plus 2x squared minus 3x. Now minus 7 minus 3. So you think if it's minus 7 degrees, and it drops 3, so 1, 2, 3, minus 10. So minus 10. Over x minus 2. Oh, is equal to q of x. Now, let's do some polynomial long division. I'm going to zoom in a bit. We got our x to the 3 plus 2x squared minus 3x minus 10 x minus 2. So, when we do our polynomial long division, we're going to say x to the 3 times what will give us x. X times what will give us x to the 3. Now, x squared times x will give us x to the 3. x squared. Now, we've got x squared times x. It's going to give us x to the 3. X squared times minus 2, so minus 2x squared. We're going to minus this one from that one. So x to the 3 minus x to the 3 is going to be 0. But we actually don't write this one because it should always cancel. Now 2 minus minus 2, which is going to be the same as 2 plus 2, going to be 4x squared. Going to bring down our negative 3x. Now, what do we need to times x by to give us 4x squared? So we're going to need to times it by 4x. So plus 4x. Now we're going to go 4x times minus 2 is going to be minus 8x. And x squared times 4x times x is going to be 4x squared. Put a little minus sign. So now, these ones will cancel. Minus 3 minus minus 8. I like to just use a calculator because the minuses always trip me up. 5x. So, what do we need to times x by to give us 5x? We're going to times it by 5. Now 5 times minus 2 is minus 10. And look at that, we have 0 remainder because those will cancel, and minus 10 plus 10, because it's minus minus 10, will give us 0. So, q of x is equal to x squared for x plus 5. Let's check our solutions. X squared plus 4x plus 5. There we go. Feeling good. I'll just make it so we can't see those solutions. These are the questions. Okay, we'll do question 54, Math Extension 1 HSC 2015. Consider the polynomials p of x equals x3 minus kx squared plus 5x plus 12 and a of x equals x minus 3. From part I, you've shown that k equals 6, given that p of x is divisible by a of x. Find all the zeros of p of x when k equals 6. Okay. So, we are going to need to do, let's head back to here. There's a good amount of space. Let's go right here. Okay, so our polynomial is x to the 3 minus kx squared plus 5x plus 12. So that's p of x a of x is equal to x minus 3. So a of x So it says from part I you've shown that k equals 6. Okay, so let's put that in. So x 3 minus 6x squared plus 5x plus 12. So there are two ways we could solve this. First way is we can use our roots and do a three-way simultaneous equation and solve for the roots. Or we can do polynomial long division, which we are going to do the polynomial long division. So let's put up our little divisor thing, x minus 3. I didn't think that through with that space there. Anyway, so x times x squared will give us x to the 3. Put our x to the 3. X squared times minus 3 is minus 3x squared. Little minus. These two will cancel. Minus 6 minus minus 3 is minus 6 plus 3 is minus 3x squared. Let me just check that in my calculator. Minus 6 minus minus 3. Yep. Plus 5x. Okay. So x times minus 3x will give us minus 3x squared. Minus 3x times minus 3. Negative times a negative will give us 9x, so plus 9x. A little minus sign there. So 5 minus 9 minus 4x. Bringing it down up plus 12. So, x times minus 4 will give us minus 4x. So minus 4. And then negative 4 times negative 3 will give us plus 12. We got out minus 4 times x, so minus 4x. Minus, and all this will come out to 0. So, our factors so far are x minus 3, x squared minus 3x, minus 4. So, let's now factorize this here. So what will the factors of that be? So we need two numbers that times together to equal negative 4, and the plus together to equal negative 3. So, if we do minus 4 and plus 1, because minus 4 times 1 is minus 4, and minus 4 plus 1 is minus 3. So, we get x minus 3 x minus 4 x plus 1. Now, the zeros of this is just when we set these here equal to 0. So if we set x minus 3 equals to 0, neat little trick we can do is we flip this sign, and then the 0 will be this sign flipped, and then that number. So it'll be 3 plus 4. Now we're going to flip the minus into a negative, negative 1. So let's check our solutions. Which question was this? This was question 54. 3, 4, negative 1. That's exactly what we got. keep going. Let's see if we can find any other good ones. Math extension 2. Not doing that. There we go. We have finished that. Did some fun little questions. Look at all that polynomial working out. That was good. We got through some polynomial questions. I hope you guys learned something. And I'll see you in the next video, hopefully.